All right, good afternoon. Thank you for joining us today. So today's presentation is an overview of our wireless access points. We've got a lot of access points out there. We've got some technology that may be exclusive to us or at least rare to find out there from other vendors. So we're going to go through all of that. We'll start by talking about some of the different technologies. Then we'll go through sort of the lineup of our existing access points. And then we've got a new access point that should be hitting distribution in the next 1 to 2 weeks. So I'll have a slide in here where we sort of introduce that to you guys as well. As we go through, if you have any questions, use the question and answer interface, and I'll answer them as we go through to the best of my ability here. So we'll start off with, when it comes to our products here, we are splitting up our VAR-focused access points into two categories, the flexible category and the ultimate category. So what's the difference between the two? The flexible category are going to be our 1 and 2 series products. So things like the NWA 1123 ACV3, NWA 210, etc. So these are access points that can be managed directly through a built-in web GUI interface on the AP itself, or they can be managed with our free Nebula cloud. So the step up to the ultimate series, those are going to be our access points whose numbers start with 5 and 6, or I should say 3 and 4 digit access points. It starts with the numbers 5 and 6. These are our Nebula Flex Pro products. So in addition to cloud management, in addition to direct management, these also work with our NXC and our USG products as a local area managed device. So you can turn your existing USG Flex device, your ATP device, they have a built-in wireless LAN controller, and you can use that to manage these access points as well. These products also in general are going to be where you find some of our advanced features like smart antenna, dual optimized antennas, etc. So when it comes to all of our access points, we have a design philosophy that we apply across the board. So anything that's designed for our VAR base here, any 3 and 4 digit APs starting with 1 and going up are going to follow this design philosophy. So when we're looking at these types of products, one of the challenges we run into is there's solid states. There's no moving parts that could break, but there is failure over time. So our design has been taking that into account to try to minimize that. And this is the reason why we can offer a lifetime warranty on our $100 access points. So one of the leading causes of failure on these guys here is what we call heat fatigue. Heat builds up inside the units. The chips themselves get warm, and that can cause the little switches in your microcontrollers to fail. Heat can also cause problems with the solder, giving you cracks in your solder joints. So to combat that, what we've done here is our housings have a ton of ventilation all through the back to allow heat to rise up through the back of the unit. We also have a very large heat sink that goes behind the PCBA that pulls the heat off the board so it can then vent out through those holes. And that's the reason why if you grab one of our access points and you grab one of our competitors' access points, you will notice ours feel a lot heavier. The other thing we've done is we have eliminated the use of electrolytic capacitors in our devices. So those are capacitors that are filled with what's essentially a saline solution of sorts. And those can leak, they can boil over, they can inflate. So we've eliminated those entirely. We're only using solid state capacitors. And again, that's all of our APs from the 100 series and up. So the 1123 V3, NWA 110AX, etc. The other thing you will notice when you look at our board is we have a lot more shielding on our board than most of our competitors do. So while this is designed to help a bit with EMI at the board level, more specifically, this extra shielding has been put in place to help filter out 4G and 5G signals. Now, if you're talking about a tower outside down the block, not a big deal. But what we see is in situations in larger buildings where people have cellular distribution systems in the building, it's very easy for those bordering 4G and 5G frequencies to cause interference. So this extra shielding helps allow us to help filter that out and give you just that much better of a connection. The other thing you will notice is that our antennas are not mounted onto the PCBA. Even some of our more expensive competitors like Ruckus will mount their antennas directly onto the PCBA. Instead, we have them separated onto their own board. And in most models, we have a noise spreader that goes between them and the PCBA. This just gets us a little bit better isolation on those RF frequencies. It gives us a little bit better signal to noise ratio. So on a good, strong connection, not going to make a lot of difference, but those edge cases, those users that are right on the borderline of where they can get a connection or not, this can make a big difference in allowing them to be able to have a reliable connection where other APs would not. So another one of our technologies that you will find on our devices is what we call dual optimized antennas. So your typical access point has one fixed antenna in it, or one fixed set of antennas inside of it, and they're usually optimized to work in what's sort of like an umbrella pattern. They're assuming that you are mounting the access point on a ceiling facing down and providing coverage to an area directly underneath it. Unfortunately, out there in the real world, you don't always get to mount your access points on the ceiling. Oftentimes you end up mounting them on the walls. And so the challenge you run into here is now your access point is mounted 90 degrees from what the antenna was designed to cover. So you end up sending a lot of your signal up into the ceiling, down into the floor. And depending on the building construction, you can cause interference going upstairs and downstairs like that between the different floors, or you're just getting, suboptimal coverage. So our solution to this is what we call dual optimized antennas. We have built two sets of antennas into these access points. One that's optimized for your traditional ceiling mounting, and one that's optimized for being mounted 90 degrees on the wall. And you can switch between those two. So you can standardize on one AP and be able to set it to ceiling or wall based on where you end up installing the device. The other kind of unique feature we have here is smart antenna technology. So smart antenna is something that's basically just us these days and Ruckus. So I want to talk a little bit about that for those of you that aren't familiar with it. We're going to sort of back up a little bit here and talk a little bit about how RF works. I go into much more in depth on this on our Wi-Fi 101 webinars. But the short version is when it comes to Wi-Fi, you're using radio frequencies. And for the most part, only one device can transmit at a time on the same frequency. If two or more devices transmit at the same time, you get interference, packets get dropped, things have to be rebroadcast. So when it comes to Wi-Fi, a typical channel here on 802.11 is 22 megahertz in size. Unfortunately, the entire 2.4 band that we can use here in North America is only about 60 megahertz in size. So you end up in a situation where you've only got 3 non-overlapping 2.4 channels that you can use. And in your house might not be a big deal, but in an office situation where or a hotel where you've got a lot of different access points, you quickly end up in a situation where you've run out of channels to use. You have to start duplicating them and you run into interference issues. On top of that, this 2.4 gigahertz spectrum is also being used by all sorts of other wireless devices, wireless printers, Bluetooth devices, non-Bluetooth wireless devices, etc. So those can all cause interference. To make things worse, part of the way we get the faster speeds in 11N and newer technologies is by increasing the size of the channel. So on the 2.4 spectrum, they've increased it to 40 megahertz in size. Again, there's only 60 megahertz available to be used. So what you end up with is a situation where, if you're using 40 megahertz channels to get those faster speeds, as soon as you add a second device, you are going to have overlap and you are going to have interference issues. 5 gigahertz is better for us. There's a lot more channels available. So if we look at 20 megahertz channels, there's something like 26 non-overlapping channels that can be used. But you'll notice here, a lot of these channels are highlighted in orange and called DFS channels. So what is that? So this frequency spectrum has been in use, particularly for use by radars, for a long, long time. When the FCC decided to open this up for unlicensed use, they had the problem, which is the people that have already deployed their radars aren't going to change to new frequencies. They aren't going to move them. So the FCC said, well, here's what we can do. There isn't radar everywhere, and those radars may only be using a tiny portion of the spectrum in that geographic location. So they gave us DFS, and it basically says before an access point can start using one of these DFS channels, it has to go through a process where first it listens and verifies that there is no radar or other legacy user currently using that channel. And then once it's cleared that, then it can start broadcasting. But as soon as it detects that somebody else's legacy device is using that frequency, it must stop broadcasting. So because of this, we have a problem, which is it can cause users to randomly get disconnected for up to a minute at a time. If your AP thinks it detects a legacy device. And, it could be detecting a radar from, whether it be a weather station, whether it be an airport, or it could just be picking up some sort of RF interference from nearby industrial equipment, which it mistakes as being a legacy user. The other problem we run into with this is getting this DFS certification adds months to the sort of FCC certification process for a device. So because of that, you find that a lot of consumer class devices tend not to support these DFS channels. So it runs into a situation where if you're using DFS channels and you're allowing people to use devices from home, you may have users that can't get on your network, they can't see your network because you're using those DFS channels. So for that reason, you often find is people choose just to avoid those DFS channels and just focus here on the green sections where you don't have to worry about DFS. But that makes a significant reduction in the number of channels, right? You go from like 26 down to just 9 non-overlapping channels. The other problem we've run into, we discussed before, is we've been increasing the size of the channel we're using to increase our speeds. So 11N allowed us to start using 40 megahertz channels. 11AC allowed us to use 80 megahertz channels, and 11AC Wave 2 and now Wi-Fi 6 can use up to 160 megahertz channels. So you can see here, you go up to an 80 megahertz channel, you end up in a situation we've only got 2 non-DFS channels to use. So because of that reason, you often run into these channel overlap or co-channel interference issues, even in the 5 gigahertz spectrum. So smart antenna solves that for us. So we're just showing here, you've got 2 devices operating on the same channel. It causes interference, which can degrade the performance of your network, sometimes quite significantly, depending on the source of what it is. So the traditional way of dealing with this has been, spending a lot of time carefully planning your channels, trying to keep devices away from each other that are using the same channel, which is great if you control everything in the building. Not so helpful if you're in, an office building where you've just got one office among many and you have no access to control what your neighbors are doing with their access points. And again, if you're using those wider channels, you're going to end up with overlap pretty quickly anyways, even if it is just something that you have total control over. So by reducing the power also, you can then reduce the coverage area of the access point, and that will end up reducing the interference, but now you're trading one problem for another, and that is you're going from co-channel interference issues to you may be lowering your signal to noise ratio to the point where it can interact or cause issues with your users. So something to keep in mind. So the way Smart Antenna has decided to handle things here is by using lots of antennas. So basically, we've got an antenna array that has the ability to go through hundreds of different antenna patterns. So what you see here is here's your typical scenario. You've got your one AP covering your room, and you've got a source of noise. In this case, it's a microwave. It could be all sorts of different things. And as you see, when that device starts putting out interference or putting out its own RF usage, it causes interference, which can cause performance issues to your users. With smart antenna technology now, same situation. What'll happen is our access point in basically real time will be able to go through hundreds of different antenna patterns and choose the pattern that not only optimizes the signal pattern coverage to direct the signal towards the user it's talking to, but also to be able to ignore the source of interference by creating a custom channel that does that. So it's something that's really nice to use in situations where you've got sources of RF interference. It also helps a lot in situations where you've got lots of users on one access point, or where you've got lots of access points in the same area. And again, we go through some of the reasons why that is and some of those issues in our Wi-Fi 101 presentation. So that's another webinar I do about once a month. So if you're interested in that, go check it out. Sign up for the next one, or you can watch a recording on our YouTube channel. So just showing here, we did some of our own testing here on performance. We compared two products here. We compared our WAX 650S Smart Antenna Wi-Fi 6 AP to an Aruba that is also a 4x4 Wi-Fi 6 AP that does not have smart antenna technology. And as you can see, the green lines here, much better performance in the same environments, particularly here in the edge cases where the signal quality, where you get really far away from the access point. So there was some third-party research that was done on this. It's the University of Brescia, which I'm probably pronouncing wrong. Their networking group got together, saw the claims that people like us and Ruckus made about smart antenna, and decided to test it. They bought one of our APs. They bought a similar Ruckus AP. They bought a Cisco AP and an Aruba AP. Cisco and Aruba don't have smart antenna, and put them to the test. And what they found is, in a clean room environment, doesn't make much difference. However, in a real world situation where you are going to have sources of RF interference, smart antenna made a huge difference in performance. And in addition to that, our implementation did a much better job of handling RF interference than the other smart antenna vendor that they tested there. So now we'll start talking a little bit about Wi-Fi 6. It's still a relatively new technology, and I know we've got a number of partners out there that have not yet made the jump to deploying it. So we'll just talk about it in broad terms here. Wi-Fi 6 products, in theory, can claim up to a 10 gig data rate connection. And again, this is Wi-Fi, and just like any other form of Wi-Fi, the performance you're going to see if you connect and do a speed test is going to be somewhere in the neighborhood of around 50% reduction to whatever the overall data rate is, because Wi-Fi has a lot of overhead that allows it to basically work the way it should. It's designed to increase capacity, allow you to have more users on the same access point before you run into issues. And Wi-Fi 6 is the first new Wi-Fi technology since 11N, which not only improves performance on 5 gigahertz, but also can be applied to the 2.4 radio. So your 11AC devices are only 11AC on the 5 gigahertz radio. Now with Wi-Fi 6, both radios can be Wi-Fi 6. But as we'll talk about here in a couple slides, not everybody has chosen to actually put Wi-Fi 6 on both of their radios. So some of the cool stuff that they've done here to allow some of this to happen is basically, up to this point, we were using what's called OFDM for slicing up the channels. And it basically forced us to use 20 megahertz channels, as we were sort of talking about before, with speed and using Wi-Fi. Now, with Wi-Fi 6, we have OFDMA. So this allows us to segment up the market into tiny little segments. So if you're doing a multi-user situation where you have multiple users transmitting at the same time to the same AP, you can do that without issues, in part because now you can divvy up the bandwidth much more efficiently. So a small little, a small little, smart home plug that doesn't need a lot of bandwidth can be just assigned a tiny bit of the available airtime, and other devices that need more bandwidth can get bigger chunks of the bandwidth applied to them. We also have the ability to reuse some of the spectrum and reduce interference between neighboring devices. And they do that by using a technology called BSS coloring. So what you'll see here is with Wi-Fi 6, they've implemented some new technologies that solve some of those same Wi-Fi issues that smart antenna solves. And the nice thing here, though, is that smart antenna goes about doing it in a different way than Wi-Fi 6 does. Wi-Fi 6 has changed the way Wi-Fi operates, changed some of the RF behaviors. Smart antenna is a physical change to the antennas that solve some of these same issues. So these are complementary and can be combined together. So you can, basically double up your improvements by using smart antenna on a Wi-Fi 6 device. So one of the challenges we run into is when you have lots of users on your network is that Wi-Fi, pre-Wi-Fi 6 was really bad about divvying up airtime. So what happened is as you added more clients onto a Wi-Fi 5 11AC device, your airtime utilization and your aggregated throughput would actually drop. And part of that is co-channel interference. You would have multiple devices broadcasting at the same time to the same AP. Um, and so the airtime utilization would be poor and your overall aggregated throughput would drop. With Wi-Fi 6, there is basically no drop in your aggregated throughput as you add additional users onto your wireless network. So this brings us to our slide here, when Wi-Fi 6 isn't Wi-Fi 6. So Wi-Fi 6 has a lot of these cool features, but technically they're optional. You might remember with 11N, they had pre-N products that came out for a good year or two. Then they had true 11N. 11AC, you had wave 1 and wave 2. And Wi-Fi 6 is sort of the same thing here, only unfortunately, the industry is just calling everything Wi-Fi 6 rather than differentiating between the two based on the feature set. So it can cause some confusion, and you can see some significant performance differences between what would seem to be the same product, on the surface. Both are 4x4 Wi-Fi 6. And the reason for that is because the early Wi-Fi 6 chipsets are missing some of these key features, and there's no way to upgrade them with software. You have to go up to a newer generation of the chips. I've got a comparison between Gen 1 and Gen 2 Qualcomm on there. It's very similar with Broadcom products. So in the case here of Qualcomm, you'll see you do have OFDMA on those Gen 1 products, but only from the AP to the users, not going from the client devices back to the AP. So it means that you can very efficiently send data simultaneously to multiple users, but you can't as efficiently have multiple users send data back to the access point. Same thing here, upstream MIMO. Missing on those Gen 1 chips. TWT, which is an improvement that allows you more efficient use of airtime, that's missing on the Gen 1 chips. BSS coloring, one of the technologies that helps allow you to put more APs in the same area without having interference issues, missing from those Gen 1 chips. So when it comes to Zyxel, all of our VAR focused products, so these are our access points that are 3 or 4 digits in length, 110AX, 650S, those all are using Gen 2 or newer chips. They all support the full Wi-Fi 6 feature set. Now, our sort of consumer-focused APs that we sell on Amazon right now, the NWA50AX and 55AXE, they are missing some of these features. It is a newer chip, but it's from a different vendor, and it's a very affordable chip, which is why at the moment you can buy an NWA50AX for $65. It is missing some of those features. It just doesn't have the horsepower to be able to enable them all. Another thing we've run into here is certain vendors, Ubiquiti, have been putting Wi-Fi 6 only on the 5 gigahertz radio. So your Wi-Fi 6 AP is only Wi-Fi 6 on the 5 gigahertz radio, where the 2.4 is still using Wi-Fi 4 technology. So something else to keep in mind when you're shopping around is to check for these sorts of things. There's a lot of different vendors out there, and I can't compare them all. But these are things to look out for, is some of these stuff here. So, and a lot of the cheaper APs, you're either going with a lower horsepower chip that is missing some of these features. You are looking at using just an older chip, which you can buy cheaper, which is missing some of these features, or going the route of only using a Wi-Fi 6 chip on one of your radios, not both. So something to keep an eye on. Generally, as you get into the more expensive APs, they'll all feature these things. So again, when it comes to Zyxel, everything that's an access point that's 3 digits or 4 digits in length, and Wi-Fi 6 is the full Wi-Fi 6 feature set, and on both radios, the 2.4 and the 5. So now we'll just talk a little bit about local area management. This is something we've tended to sort of neglect recently, as our focus has been, you should use the cloud to do management. But I recognize there is still a lot of you out there that either yourselves aren't sold on the cloud, or your customers aren't sold on the cloud, or for whatever reason, it's just not going to work in your particular environment. So let's talk a little bit about local management through a controller. So we still do offer that. And you'll see here the feature set between this and between using cloud management are very, very similar. Both sets here will do dynamic channel selection. Both are 0 AP config deployments. So when you are using one of our controllers, our manageable APs will see that there's a controller on the premise that's enabled, and they'll automatically connect to our controller. So you don't have to log into each AP and tell it here, here's the IP address or here's the URL of your controller. They will find it automatically. We offer mesh on both versions here, fast roaming, 802.11 KVNR. The on-premise controller does allow us to do rogue AP detection, something that the Nebula Cloud does not let us do. It also allows us to do some more tougher security at the edge here. So we've got the typical 802.1x authentication and things like that. But we also have the ability to generate a tunnel directly between your access point and the gateway. So all traffic has to go through your firewall gateway so you can apply security filtering to your wireless users. We support dynamic VLAN, AP load balancing, client isolation, so users can't send data to each other, really handy for guest networks, band steering, captive portal, all the stuff you would expect to find in a on-premise controller. And for the most part, same features you would find in the cloud. So which products can you manage it with? We've still got some of our NXC 2500 dedicated controllers around, but for the most part, you would be using our Zyxel USG series type products. So the VPN series, the USG Flex series, the ATP series all have a built-in wireless LAN controller. So you can see here, this column is showing us out of the box how many APs can be managed. So you can see here a VPN 50 can manage 4, whereas a USG Flex 700 will manage 8 out of the box. And then on the ATP series, it is tied into having a gold pack. So most of our products, I think we sell them only with the gold pack out of the box. So that would get you on an ATP 100, 24 APs out of the box can be managed. And then you see here, we can upgrade those through licenses to unlock additional APs. So we top off here, our VPN 1000 can manage over 1,000 access points. So there are some good third-party reviews out there. Feel free to check those out on YouTube. You should find some good reviews here. Network Advisor has done, I think, 2, possibly 3 comparisons between us and some other vendors. And there are a couple other ones out there. I think CNET, or formerly CNET Reviewer, has done some as well. So feel free to check those out for a third-party viewpoint on how our products perform. And now we'll finally start going through all of the models that are available. So just to let you guys be aware, a lot of the 11 AC models will be phased out at some point this year. So I'll sort of highlight here which ones are sticking around, which ones will eventually be phased out. So this is our 1 series products. So these are our Wi-Fi 5 ones. So you can see here, we've got our NWA 1123 ACV3. This is our entry-level model here. It is 11 AC Wave 2. This guy is sticking around and will be here for a while. The next 2 models here, these will go away at some point. So we have our NWA 1123 AC Pro, very similar to the Ubiquiti UAP AC Pro, only we offer a lifetime warranty, local phone support, and dual optimized antennas for what should be right around the same price point for you. These right now we're heavily back ordered on. That should be solved sometime in late spring. So we will have these more, but they probably aren't going to last us through the end of the year. We've got our NWA 1123 AC HD. So this is a 3x3 11 AC Wave 2 access point, and all of these can be managed with Nebula. On the Wi-Fi 6 side of things, we have the NWA 110AX and the 210AX. Primary difference between these two is the 210AX has double the speed on the 5 gigahertz radio. And to help support those faster speeds, this has a 2.5 gig multi-gig connection so that your Ethernet connection doesn't become the bottleneck for your network. Going forward from there, we're jumping up to our 5 and 6 series. So these products can be managed with Nebula, and they include a 1-year ProPack license with them that you can use should you choose to. These can also be managed with one of our local area controllers, one of our Zyxel products. So the entry-level product here is the WAC 500. This will be sticking around for quite some time. Basically the upgraded version of the 1123 V3. And then these two guys here will be going away some point later in the year. So our 5123 ACHD, it is a 3x3 Wave 2 access point. And then the 6303, which is our most affordable 11AC smart antenna access point. So if you want that smart antenna technology, the WAC 6303D-S is your entry point. And then for those of you guys doing hospitality, we have these dedicated hospitality access points with PoE and Ethernet pass-through. We have the WAC 500H and the WAC 5302D-SV2. Primary difference between the two is this one here is a smart antenna product, where this one here does not have smart antenna. Then for our ceiling mount Wi-Fi 6 APs here, our entry point is the WAC 510D. 2x2 on both radios, Wi-Fi 6 on both radios. Step up from that is the 610D. Now the main difference between the 510 and the 610 versus the 110 and the 210 is in addition to the Nebula ProPack license, in addition to working with our local area controllers, these ones also both featured our dual optimized antenna technology. And then our flagship product here is the WAC 650S. It's 4x4 on both radios, Wi-Fi 6. It has a dedicated third radio for doing scanning. So in the cases of, for instance, DFS, you can use that third radio to constantly be scanning the other channel, so your device knows if it has to stop using one channel, which channel it can go to immediately without needing to continue scanning. It also has a fourth radio for doing Bluetooth. So for those of you that are doing BLE type stuff, that is supported here on our 650S. And this guy here has a 5 gig multi-gig Ethernet connection to be able to provide the wired bandwidth to support those faster Wi-Fi 6 speeds. Also, this guy here is our only access point that requires you use an 802.3 BT PoE device to be able to operate at full speed. If you use an older 11AT device or switch or injector, it will still work, but at much slower speeds. So again, for this guy here, this is the one that needs to have the BT. We have a couple switches that offer that BT power. We have a dedicated PoE injector you can buy that offers that higher power, or you can buy a AC power adapter from us for like $15 that can fully power it as well. All the rest of the Wi-Fi 6 APs work just fine with a standard 802.3 AT PoE device for power. And then on the outdoor side of things, both of these will probably be going away at some point later this year. We don't yet have a Wi-Fi 6 outdoor solution that I can share with you. It is something that is in the works though. And the primary differences here is this one has smart antenna, but it's designed to be a very narrow band focus. I think it's officially a 90-degree band that it covers. So the idea behind this one here is to make it easy to do point-to-point. So because of the smart antenna and our ability to change and modify through the antenna itself where the signal goes, it makes it a lot easier to line up those point-to-point outdoor links. You don't have to be as picky about getting things, dialed in, because the beam is pretty large, or the area where the beam can form is very large. You can also stick 4 of these on the same pole to provide 360-degree coverage. And then we've got our WAC 6553D-E. This is our 3x3 outdoor AP. It uses external antennas that you buy separately, our ANT 2105. And this one has a heater built in, so it can handle temperatures down to -40 for cold starting. And then we do offer this guy here. This is an outdoor enclosure that fits the majority of our APs at the moment. So if you're looking for an easy solution, a cheap solution to go outdoors, buy an inexpensive indoor AP, mount it into our outdoor enclosure here, and then you can use your indoor AP as an outdoor AP. And let's see here. And then I want to talk here about our new guy. This is the WAC 630S. So one of the complaints we had gotten on our Wi-Fi 6 line has been, you've got the WAC 650S, which is great, but it's expensive and it's more horsepower than I or my customers need. So this is going to be now our entry-level Wi-Fi 6 smart antenna access point. It's essentially a WAC 610, but with smart antenna built into it. So it's a 4x4 on the 5 gigahertz radio, 2x2 on the 2.4, Wi-Fi 6 on both of those radios. So this guy here is a sub $400 access point now that gives us Wi-Fi 6 and smart antenna together. So I'll do a few slides here comparing us to some of our competitors. So we'll start off with our NWA 1123 AC Pro, one of our best sellers there. And the big competition here in this space is Ubiquity's UAP AC Pro. So both are 3x3 11 AC products. You will note here we have much higher output power than Ubiquity does, 27 dBm versus 22. We support more SSIDs, 8 SSIDs per radio versus 4. We offer our dual optimized antennas on this design. Ubiquity has just the standard traditional ceiling umbrella coverage. Little bit better antenna gain on the when it's in wall mode there. We support SNMP V2C and V3, whereas the Ubiquity only supports SNMP V1. And then probably here, the biggest difference is we support a lifetime warranty out of the box on this. The Ubiquity does not. Pricing should be almost equivalent between these two models out there through distribution. So we'll jump up here to a Wi-Fi 6 product. Let's do the Wi-Fi or the WAC 510D. So we're comparing it here to Aruba's AP505 and Ingenious. So Ingenious has two models. They have a 357 and a 220. Both are the same hardware. One can be cloud managed, one can only be local managed. So differences here, we offer dual optimized antennas. Both of these guys only offer the static single antenna. But probably the biggest, most important thing here is the Ingenious product, even though it's marketed as Wi-Fi 6, is one of those products that is using an older chip that is missing some of the key Wi-Fi 6 features. So you're missing out on the upstream OFDMA, you're missing out on the upstream MIMO, you're missing out on BSS coloring on Ingenious versus our 510D. You'll also notice we have more power than both of our competitors coming out of the chip. And only ours allows you to do controller managed, local managed, and cloud managed on the same device. And then lastly here, we'll talk about our WAC 650S. So this is our flagship product. This is a 4x4 Wi-Fi 6 with smart antenna. So you can see here, we're comparing it with a bunch of different stuff. Probably the main guys you guys will run into is the Meraki MR45 and the Ruckus R750. So you'll notice only us and Ruckus offer the smart antenna technology. We offer higher output powers again than most of our competitors do here. Only us and the Meraki have that third dedicated monitoring radio. The Ruckus does not have that. And when it comes to these here, only us and Aruba have the 5 gig backhaul. So because of the speeds that you're getting here, you really do want a faster than 2.5 gigabit connection on your Ethernet if you can. So we've got the 5 gig backhaul here to make sure that your wired connection is not bottlenecking your wireless users. And again, we've got the ability to manage it in the cloud for free, directly, or using a local area controller. And that, guys, that ends today's webinar. I haven't seen any questions come in, so if you have a question, please send them in using the question and answer interface. In the meantime, be sure to check us out on YouTube, Zyxel America channel. All of these webinars that myself, Tri, and Marcus do are all recorded and then are uploaded to the cloud. So if you've missed out, you had to step away, you can always watch the recording of it. Or if you've got something you want to learn about, but you're not going to be available the day that we have the webinar, you can find a previous version of that presentation on our YouTube. So we are on YouTube as Zyxel America channel, all one word. And then, of course, we're up there on LinkedIn. And then I just also want to draw your attention to our forum, forum.zyxel.com. These are user forums primarily, but they are monitored by our team in Taiwan, both R&D and product management. So oftentimes they will wade in to answer questions. They will see the feedback you give there. And on top of all of that, that's where the first place where stuff gets released. So release notes when new firmware comes out, security advisories always get posted to the forum first. So check that out. All right, so we've got some questions. So Rick is asking here, when do we expect to have a true Wi-Fi 6 outdoor radio? And the answer to that is, I don't have any data I can share with you. It's something we are working on. One of the challenges we've run into is we are trying to do it with Wi-Fi 6E products. And as I understand it, the standards have not yet been set for testing outdoor Wi-Fi 6E. Wi-Fi 6E can be used indoors. We would like to offer it on our outdoor products. So we're waiting for that to get solved, and then just for the chips that have the full feature set we need to be available. So whenever those two things are solved, we'll hopefully have our products shortly after that, but I can't tell you when. In the meantime, most of our Wi-Fi 6 products do fit in our outdoor enclosure. So you can always combine them with our outdoor enclosure in the meantime to create a Wi-Fi 6 product or Wi-Fi 6 outdoor product. Richard is asking about trade-in value for, we do offer a trade-in program. I believe the access points are covered on it. Your sales guys would know for sure, but I think that's correct. So I'm assuming you're one of our partners. So Jacob, Andy, David, or Try, they could answer that for sure, but I believe we do have a trade-in program on APs. And that looks like that's it for all of our questions. So I'm going to go ahead and end today's webinar. Thanks for turning out, guys. I appreciate you listening to me here. Thank you.